first topic should have been in week 11. I'm not sure why I got in here. Sometimes ALEKS moves stuff. So this has a lot to do with the compound interest. This is actually finding the present value. Okay, so you want to have this much money at the end. So how much should you start with? So yeah, this has to do with last week's the week 11 module. So to help with his child's college fund, Chris needs to invest. Assuming an interest rate of 2.27 compounded quarterly, how much would he have to invest to have $79,400 after 12 years? So we are going to use, not that calculator. Did I lose it? I don't know. I did. The compound interest calculator. That is there on Canvas for you. So we are trying to figure out how much he needs to start with. So we want to find the principal using the ending amount, which is A. I kind of feel like we did a very similar problem like this last week or last time too. 79,400. This section is very calculator heavy, so we will do a lot of stuff with the calculator. And we got 2.27 quarterly for 12 years. 2.27 quarterly. So N is equal to 4 because I'm doing it 4 times a year for 12 years. And you get your answer right there, 60,500. So if he starts with 60,514, 2.27% compounded quarterly in 12 years, he'll have 79,000. So it grows by 19,000 without him even doing anything. So yeah, that kind of fits last week a lot better. So what we're looking at this week is annuities. This is an annuity is like a series of payments made at regular periods. So like on that compounded one, they kind of just put one in. So you have annuity payment. So it's like how much you're putting in every month or every year, whatever, to turn into something. This is kind of the more real life one. What we do is because we make a car payment every month or we try to save every month. So here Sam wants to save money to purchase a car. He buys an annuity with the quarterly payments that earn 2% interest and they're compounded quarterly. Payments will be made at the end of each quarter. Find the total value of the annuity in 5 years if each quarterly payment is $918. Okay. So we have this calculator again on Canvas. This is the future value of annuity calculator. This is not the one I was using. Sorry. Let me just go back to Canvas, make sure I use the right one. All right. So the hard thing about this one is you have the number of periods. That's always going to be your years. Okay. That's how many years you're doing it. And then you have how many it's compounded. The rate's obviously easy. So the number, let's just do this as we go. 5 years. So 5 years for the number of periods. My rate was 2%. We are compounded quarterly. So how many times does it compound a year? It's going to compound 4 times because it's quarterly. And he's making quarterly payments of $918. Okay. So we're doing $918, but then you also have to say how often you are doing the payments. I believe on ALEKS, it matches all the time, okay? How many times you compound is how many times you do the payments. It's not always true in real life. Sometimes it compounds annually and you make monthly payments. That's the way it works a lot of the time. So when you look at this, that is the hard part. So the number of periods is the years. Then compounding, you got to read the question to see what it says. And then how many payments you make a month, you got to see what it says. So it will tell you whether you're making an annual payment or a monthly payment or quarterly payment. The other thing that we don't ever have to change here is this last little drop-down box. This is when do you do the payment? Like, do you do it at the beginning of the quarter or at the end of the quarter? We never change that. ALEKS always does the end. That's called an ordinary. But that does make a difference of like how much interest you're getting, whether you do it at the beginning or the end. So it can draw interest for, if you do it at the beginning, you do it all the way to the end. But if you do it at the end, it doesn't start drawing interest till the next quarter. So we got our number there, 19,258. This is, like I said, this is very calculator heavy. And when you get to the test, what you're going to have to do is figure out which calculator to use. But the name of it should help. I've narrowed it down to 4 calculators now. So yeah, simple interest and compound interest, which we did last week. And this week the next module we're doing the annuities. And there's 2 different calculators. There's one when you're trying to find the future value, and then there's one when you're trying to find the monthly payment. So shouldn't be too hard there. An investor wants to save money to purchase real estate. He deposits $750 at the end of each year in ordinary annuity that pays 6% interest and compounded annually. So again, that word annuity tells you what to do there because you won't have the name of the topic when you're taking the test. So 750 compounded annually, 6%. Okay. So we're gonna look at each year here. It's compounded annually. What did I say, 750? And we're making one payment at the end of the year. Okay, so on this problem, we're seeing what happens after each year. So on the first year, if I make a payment at the end of the first year, I only have my original balance in there. I only have $750 in there, right? Okay. I'm gonna click solve so I don't have to type those in there. Okay. So now, like if I make the payment at the end of the year, then I only have my original balance in there. But if I change it to 2 years, so we have $750 in the first year. We earn interest on that the whole year. We put another $750 in, so that's $1,500, and we earned $45 worth of interest on that $750 we had in for the first year. Okay, and then if we do it 3 years, it is, we get, 750, but we earned, on the second year, we earned the original 750 from the first year. The next year, we earn interest on that 1545. So our interest, we've gained 137.70 now. So this just kind of shows how it grows, not at a linear rate, but it grows at like an exponential rate because you are growing money from your principal and your interest. Okay. The next one, find periodic payments needed to meet an investment goal. I believe this is the one that I had to look at the calculator last class. Amanda wants to save money to buy a motorcycle. She invests in an ordinary annuity that earns 5.4% interest compounded quarterly. Payments will be made at the end of each quarter. How much money will she need to pay in the annuity each year or each quarter for the annuity to have $6,000 after 3 years? So this is like good money management that I know that I'm going to need $6,000 in a couple of years. Like, let's start putting some money away and saving for it. This is a different website and a different calculator, but I couldn't find one on that website that does that. So 5.4% interest. We're doing 3 years. We are compounding quarterly. And what you want, $6,000? Let me check that answer real quick because I feel like, okay. So yeah, $463.95. So she would need to put in $463 every quarter, and it would turn into $6,000 in 3 years. Okay. Sorry, I was trying to think real quick. $463.95, right? So one of the things to think about here, just to like see it, 463, we did what, 3 years? And quarterly, so times 4 times every year for 3 years, so times 12. So she would only put in $5,564, and she'd get a free $400 from interest there. So that is why you do things like that and put those in there. This is the only one topic that we need this one on, but it's a annuity that you're trying to figure out the monthly payment on. All right, here's some that we kind of have to do by hand. I'm going to click solve to make sure. Well, let me show you a trick real quick. Never mind, we didn't have to do this. So I did this. Okay, so unpaid balance from April. Compute the interest. Suppose the credit card charges 1.15 monthly interest on unpaid balance from April. How much interest will this be? Come on. Oh my goodness, I'm already down to 19%. I think this screen recording like absolutely kills my battery, and I forgot to charge it last night. So, yeah, no, y'all just wash that battery because then it's like class is over when the battery ends, right? So for part A, 655.10 times 0.015. Make sure you change the decimal, and this should equal the $7.53 that she gets charged for interest. For part B, it says, what will David's unpaid balance be on the June 1 statement? Okay, so for part B, started with 65.10. We add the interest, 753. Then we add the purchases, but then we're going to subtract any payments made. Okay, and that would give us the 842. So that is just a little bit of credit cards. I may talk about credit cards for a second on Tuesday too when I do my real life math. But So yeah, you start with the original balance in April. At the end of April or the beginning of May, it's $655. You get some interest that you didn't pay, what you didn't pay in April. Then you add more purchases to it. So those are additions, and then you do subtract any payments. So it would be $842.55. I didn't even pull up my sheet here because it's all calculator. Do I even have one? Look, I haven't even put the topics there. All right, another one with the computing the daily average balance on the credit card. This one's nice. They added this chart. I don't think they used to have this chart. So this kind of walks through. So when you get your credit report, they do an average daily balance of how much you have on your credit cards and things like that. So like if you have $1,000 on a credit card through the 15th of the month, but then you pay it off and you got a zero balance for the last 15th, it still is going to say that you had money on the credit card because you had $1,000 on it for the first 15 days of the month. Okay, so it actually does find the average of how much per day you had on it, based on having $1,000 for the first 15 days and then $0 for the next 15 days. So the average is you add them all up and divide by how many there are. So what you have to do is figure out your balance for each day. Okay, and this kind of walks through how it changes. So my beginning balance on September 1st was $1,500. And I kept that balance for 11 days. So they did 1525 times 11. Okay. I don't think I need to show you how to do this multiplication on the calculator, so I'll use my phone calculator. All right, so then after those 11 days, on the 12th day, we made a purchase of $94. So we add that to our unpaid balance, so we're at $1,594. From the 12th to the 15th would be 3 days. So we carried a balance of $1,594.27 for 3 days. So we multiply those numbers to get this number, 4782.81. So every day it was $1,594 plus $1,594 plus $1,594. The easy way to do that is $1,594 times 3. Okay. So my new balance after I make another purchase for $460, I was at $1,594.27, and then I made a purchase of $460.80. Is 2055.07. Okay, and I carried that balance for 6 days, so I take that times 6. 12330.42. All right. Then I made a payment of $550, so 2055.07 minus 550 is 1505.07. And I carried that for 10 days. So that would be 15,050.7. All right. So now I have how much each day I carried. So I'm going to add them all together. 16,502.75. You know what? I got the solve button. Instead of adding those all up, I'm going to just do that. I'm going to cheat and do that. Okay. So you add all those up. That's how much every day, if I added up what my balance was for every day, and then I'm going to divide it by 30. Okay. Because there's 30 days in this month. So that 48,666 divided by 30 is my answer to part B, 1622. Okay. We can write some of this out. So on this one we did times, they did this for us, but times 11, times 3, times 6, times 10. Then you add all these up, okay? And then this one right here is the 48,666.68 divided by 30, okay? That's for B. For C, we are going to take, now to be careful here, don't go back to your average daily balance. That's just what the credit bureaus use. So go back to your original balance up here. At the end of the month, it was 15,057 times 0.017. 1505, let me make sure that's right. 0.07 times 0.017 is no. Average daily balance. It is average daily balance. Sorry. The credit card would use your average daily balance. I think it's the next. I got confused. I was thinking what I did last class. Yes, the credit card is going to look at your average daily balance to get that number, okay? I got very confused with the next step. My bad. What will Greg's beginning balance be at for the month of October? Here is where you go back and you say, okay, my balance at the end of September was 1505.07 plus my new interest. That's where I get that number from, okay? That's the one you got to go back and look at that. The credit card will use your average daily balance. So again, like if you have to pay, if you carry a balance of $1,000 for the first 15 days of the month and then you pay it off in the middle of the month, they're still going to charge you for that first 15 days because credit card companies are evil. I'll talk more about that on Tuesday. All right, the last 4 topics here are actually the easiest because they give you a calculator in here and they you don't have to use a website calculator. So I believe I tried to use more of these on the test. So it starts pretty basic and kind of walks you through there. But Amanda's deciding between 2 personal loans. For each loan is $15,000. Okay. First one is 8 years at 5.2% interest. Okay, so we click calculate. We get our number here. I'm just going to click solve so we have it. So I don't have to type it in, but 191.33. And then the next loan is for 7 years at 5.55 interest. And the payment is $215. Okay, so if this is kind of the real life thought process here. Part C is which loan has a lower monthly payment by how much. So you just subtract the numbers there. I don't really need to write that down. I think y'all got that. So loan A has a smaller monthly payment by $24.58. Okay. Now I went into this last class, but the next topic kind of leads into this. So we look at this and we say, well, I'm just going to take the lower interest or the lower monthly payment, right? Why wouldn't I just take the lower monthly payment? That's we think about our budget. We think about different things like that. A $25 difference, you might just go ahead and do the other one. But what you really need to look at, and I mentioned this on Tuesday, is the total value that you are paying of the loan for the whole thing, okay? I'm not going to do that for this problem because I think we do it on the next one. But you don't just look at the monthly payment. You want to see how much you're actually paying for whatever you're buying. So on this one, I think does that. Lisa wants to take out a car title for $8,500. The interest rate is, oh my goodness, 33%. I'd say that's strange, but I've seen some 20s in the past couple of years. So 33.59. Find the monthly payment. So this calculator gives us the monthly payment, $377.75. Find the total amount to repay the loan. So if I'm doing $377.75 per month, and I'm doing it for 3 years and every month, you can do 36 if you want to, but 3 years and 12 months, right? I'm doing $13,599. So what is the total amount of interest paid? Okay, I pay $5,099. So Amanda should probably not buy that car, Lisa, whatever her name is, should probably not do that car because she is going to waste $5,000.99. Okay, I don't know if it's because I hate big corporations and banks or whatever, but I don't want to give the bank $5,000 free dollars just for spotting me $8,000. That's a bit ridiculous. So please don't ever sign a loan that says 33% interest. That's ridiculous. That is, but this is kind of some of the stuff that I'll talk about on Tuesday. You have to. I think we do this on the next problem, so I'm trying not to say too much. But when you look at the total value and how much you're actually going to pay, you want to see how much money your interest and how much you're running. I don't want to actually pay $13,599 for a car that cost $8,000, right? So you have to pay attention to the total value of a loan that you do there. This is the one that I really want to talk about, I think. Donna is deciding between 2 personal loans for $15,500. So for loan A, for 6 years at 6.15% interest, it is $257.98. For loan B, it is 6.3% interest, but it's only for 4 years. Okay. So $366.15. All right. No. I did this wrong. That's the monthly payment. That's fine. Okay. Sorry. It says find the total amount to repay the loan A. So I got to go back and do this. 257.98 times 6 years every month. First of all, it's good. I want to talk about this. I want you all to see it. Okay, so if you walk in to buy a car or whatever, and you see these loans right here, like you automatically just pick the 257 because it's a lot easier to pay $258 a month than it is to pay $366, right? Like that's just the way our brains work. That's I'll take the cheaper loan. Like it's $100 cheaper. I can save $100 a month. I can go to Taco Blue or whatever. So like I had the $100 right there. Okay, so we just see that. And this is where you always want to look at the total value. So the total value of this loan was $18,574.56. Okay, the total value of this loan, $366.15 times 4 years times 12 months would be $17,575.2. Okay, so that is I'm gonna click solve here so I get my numbers. That is $1,000 less. Loan B is $1,000 less. Okay, so is that paying an extra or paying $100 less a month worth you just giving away $1,000 over the next few years to the bank for the fun of it? Those are like the decisions that you have to make in life when you start to do these budgets. If you actually understand what's happening here, like people mostly just look at the monthly payment and say, okay, I'll take the cheaper one. Okay, but is it worth $1,000 over the next couple of years to give the bank, is it worth $100 extra a month to give the bank an extra $1,000 over the next couple of years? I don't know. Like maybe it is. Like if you talk about $1,000 over 4 or 6 years, that's really only what, $50 a month, $20 a month. So like, I don't know. Like you save $100 a month, but you're just wasting $20 a month on interest. So this is kind of like some of the stuff that I want to talk to you about on Tuesday. Some of the different like loans and the way they work. Let's do the last one before I go into my little spiel about that on Tuesday. All right, the last one here is periodic payments to see how it grows. This is the big one that I want to talk to you about on Tuesday. Not just loans, because y'all are, I asked the other day, how many of y'all are under 20? So most of y'all, when I say things like real life money and things like that, you're like, yeah, I'm not buying a house anytime soon, or I'm not buying a car anytime soon, or I'm not going to take out loans, I want to be debt free, like all those different things. But then life happens, then you turn 40 in 10 days and you say you're going to be debt free by 40 and your AC goes out. Like that's, the way things go. Not that that's a real life story or anything. That is harder to get y'all to listen to. Like I guess I was going to say I was 20 not that long ago, but it was a long time ago. I know that's harder to get y'all to listen to, but there are some things like this one that I really want to talk to you about on Tuesday that I really wish someone would have told me when I was 20, because people come at you when you're 20 and like say, do this, like you'll do this, and it's just not realistic. I'll have that conversation in a second too. All right, so just to show you like this one and trying to save that conversation for Tuesday, so I have enough to talk about on Tuesday. Chang opened a retirement account earning 3.5% interest per year, compounded monthly. He deposited $100 each month. Okay. So what is he gonna have after 12 years? So after 12 years, what was it? 3.5% interest. So like that's a realistic number. I think my bank account right now earns like 3.8 or 3.9. So like that is a number that you can find. So after 12 years, by just putting $100 away every month, he would have $17,864. Oops, not that number. What about after 24 years? Calculate. He would have $45,036. Okay. What about after 36 years? He'd have $86,364. Okay. So like this is showing you the money grows, and like most of y'all have the basic concept that hey, if I invest money, if I put it into something that earns interest, my money will grow exponentially, not linearly. So I do get money right here. I'm gonna click solve so I'll tell you how they got those numbers in just a second. So like what happens here after 12 years, he has $17,864 in it, right? So over the next year or over the next 12 years, he doesn't get an additional $17,000. He is making money on the money that's making interest. So he actually gets an additional $27,000 instead of $17,000. Okay. So you would think every 12 years you're going to get $12,000, but since you're compounding on the interest, you actually get 17,000 the first 12 years, then you get 27,000 the next 12 years, and then you get 41,000 the next 12 years. So, like to see that money compound and double up is like the one of the things we'll talk about on Tuesday. All right, and then the last like part C here in D and E, the account grew faster over time. That is always going to be true. Like I got 17 the first 12 years, 27. Oh wait, how'd they find those? I didn't tell you all how they found those. I guess I should tell you. To find like those numbers, the first ones are always going to match because that's how much money you have after the first 12 years. To find the 24 to 12, you just subtract 44,036 minus 17,864. Okay. And that will tell you the 27. So you just subtract how much you have at 36 versus how much you had at 24, and that would tell you the next one. And those are like it will grow like that because you are compounding on the interest that you're earning. Part D, the amount of money deposited during the period was the same for each period. Yes, the money grew at a higher rate each of the 12 years, but I still just kept depositing $100 because I'm making money on my interest. The account earned more interest during a period 3 than period 1. Yes, the last period will always earn more than the previous periods. Okay. So that is that went a lot faster than last class. We had to search for that calculator for a minute last class because we couldn't have it.